Let's look at a simple example. Here we have a PMF of a random variable x given to us, and we will investigate a number of other random variables defined as functions of this random variable x. Okay, so first of all, let's look at this function y equals 2 times x. Okay, so uh, you can actually use the approach given in the previous slide where you apply the inverse transform or the inverse function method. But in this case, since we have just three outcomes, it's also not that difficult to investigate each outcome one by one and see which outcome of y they correspond to. You see, random variable x takes the value of 1 with a probability of 0.5. It takes the outcome value of 2 with a probability of 0.2 and the outcome 3 with a probability of 0.3. That means since y equals 2 times x, when x equals 1, y will be 2, which happens with 0.5 probability. Similarly, when x equals 2, y would be 4, and that happens with 0.2 probability. And finally, when x equals 3, y equals 6, and this happens with probability 0.3. Simple as that. Let's look at another one. Z equals minus x over 2. And quite similarly, when x equals 1, z equals minus 1 half, which happens with probability 1 half. And when x equals 2, y is minus 1, which happens with 0.2 probability. And when x is 3, then z is minus 1.5, which happens with probability 0.3. Okay, simple as that. Next one, let's have a more complicated expression now. V equals x minus 2 squared. Now, in this case, again, what we do doesn't change. We just look at the three outcomes and determine what outcomes of V those correspond to. So for instance, when x equals 1, put 1 here, 1 minus 2 squared gives me 1. So this happens with 0.5 probability. When x is 2, you have 2 minus 2 squared, which is 0, and that happens with probability 0.2. And when x is 3, this happens with probability 0.3. 3 minus 2 squared gives also 1. So you see I have two possible outcomes for V, 0 or 1. And 0 occurs with a probability of 0.2. And the outcome 1 occurs with probability 0.5 plus 0.3, 0.8. Okay. And finally, let's define t as this function, x squared minus 3x plus 4. Similarly, when x equals 1, t equals 1 squared minus 3 times 1 plus 4, you get 2. When x equals 2, x squared 2 squared minus 3 times 2 plus 4, and that is again 2. And finally, when x equals 3, 3 squared 9 minus 3 times 3, which is also 9, plus 4, so you get t equals 4. Okay, so this occurs with probability 0.5, this with 0.2. So together they make 0.7, and t equals 4 occurs with probability 0.3. Therefore, we obtain the PMF of t in this way.